What is radioactivity? Radioactivity is the tendency of unstable atom nuclei to emit subatomic particles. Radioactivity is seen in heavy elements such as uranium. The radioactivity unit was named Becquerel in the SI unit system because the French scientist Henri Becquerel observed the scribbles of the uranium salt released by the particles on a photographic plate in the dark. Without forgetting, Becquerel was waiting for the rain to pass through the film to leave the uranium wrapped in his drawer to the sun, and discovered that there was glow without sunlight when he bathed the film for no reason. In other words, this is a coincidence invention. As Becquerel continued her studies, Marie Curie also started working on the rays emitted by uranium, which would later be called radioactivity. Marie Curie, who discovered that not only uranium, but also thorium, had made this radiation in early 1898, announced that they had discovered the polonium after uranium's decay. Madame Curie carried out her studies with her husband Pierre Curie. She embraced the Nobel Physics Award in 1903 and the Nobel Chemistry Award in 1911 thanks to these studies. If we go into a little detail, when the atomic nucleus is unstable, it randomly decays into a stable nucleus. Radioactivity is this degradation of unstable nuclei of heavy elements. Various particles and energy are released as a result of the decay process. The nucleus of an unstable atom decays to be stable. As a result of this decay, radiation energy is released. Radioactivity is also created by nuclear fission. Fission is the cracking of heavy nuclei in a controlled or nuclear reactor. The atomic nucleus that dissolves and emits energy to create more stable atoms is called a radioactive element. Radioactive elements such as uranium, potassium and thorium are also isotopes of elements such as carbon, bismuth and strontium. Radioactivity is an arbitrary event, and the time it takes for the atomic nuclei of a radioactive element to fall to half-weight is called its half-life. What is nuclear energy? How is it produced? One way to obtain nuclear energy is the fission, nuclear division, method used in our time. Another method is the fusion, core fusion method, but studies have not made fusion efficient. When the neutron is taken, the isotopes divide, and the products formed as a result of division try to escape from that point with the kinetic energy they gain as a result of division. This means 6/7 of the total energy. This movement is the movement of the floor in the solid. As a result of this movement, nuclear energy appears as heat energy. The machines developed to produce nuclear energy regularly and under control are called nuclear reactor. The proper and reliable extraction of the heat produced as a result of the reactions and maintaining the fission reaction under control are the two most important items required for the continuation of regular production. Nuclear reactors are designed to make fission reactions happen one-to-one. As a result of each fission, 2 to 3 neutrons are released, and if the fissile isotope, low energy or non-energetic number in the environment is sufficient to enable each new neutron to fission again, this will create an uncontrolled reaction, which is the basic logic of the atomic bomb. Nuclear reactors have a mechanism called reactor heart, and this mechanism is designed to make only one neutron re-fission by removing the excess neutrons resulting from fission or allowing them to be swallowed. The main purpose of nuclear reactors is to generate energy, and they meet this requirement by pulling heat energy from the reaction. The generated heat is continuously drawn from the medium with a coolant, mostly water. The use of drawn heat in electricity generation is provided by steam turbines. Electricity generation with steam, hot gas, is not specific to nuclear energy. It is more or less the same in a typical coal or natural gas power plant. The nuclear reactor has assumed the role of heat generator in the electricity generation system, that is, it is produced not by burning heat, coal or natural gas, but by fission. Finally, there are currently 435 civilian nuclear power plants in operation, as well as 71 reactors under construction. Usage areas other than electricity production. Although its most important use is electricity generation, nuclear energy can be used by industries that also need it as a direct source of heat energy. It can be used in healthcare diagnosis and treatment, in industry, for many manufacturers of isotopes, from pacemakers to satellites and spacecraft energy generators. Submarines and aircraft carriers especially prefer nuclear energy as fuel. All aircraft carriers owned by the USA are powered by nuclear reactors. Nuclear fuel. Approximately 6 in 7 of the reactors in operation are light aqueous reactors and contain 3 to 5% fissile isotopes by design, otherwise the fission chain does not occur. Other 10% CANDU-type heavy water reactors also use natural uranium. The element taken from nature and used as a fissile isotope is uranium-235. The rate of uranium-235 in natural uranium is 7 per thousand. The rest forms the U-238. When arranging the light water reactor HSR fuel should be made using natural uranium. For this it is necessary to fix the U-235 ratio of 7 per thousand to the 3 to 5% range. It is called enrichment. U-238, which makes up 95 to 97% of an HSR fuel, is not fissile. In the nuclear reactor it turns into plutonium-239. Because of this feature it is called fertile. Pu-239 is a fissile isotope and it generates energy by fission on the one hand while it is emerging in the reactor. It is not found as an element in nature and its contribution to energy production is 40%. Environmental waste, risk and accidents. A 1000 MW reactor releases 30 tons of used nuclear fuel per year. It uses 3 million tons of coal to a coal power plant of the same power and produces 7 million tons of flue gas. Although nuclear energy seems much more innocent compared to this, the slightest negligence, mistake or accident, which is inherent in people such as making a mistake even if negligence is disciplined, is very difficult to get back, and some of it will lead to uncompensable results. Namely, radioactivity can pass anywhere, not only through rock, soil, and especially lead Pb. This production, which holds the risk that can change its quality by penetrating human DNA, has the risk of negatively affecting the entire ecosystem. For years, scientists such as Marie Curie, Pierre Curie and Becquerel have worked for years to produce an alternative type of energy that will not harm the environment, such as coal, and to reveal an unknown power. Madame Curie was just learning about the effects of radioactive substances on living things, and died in 1934 due to blood cancer caused by radioactive substances. As a result of the ongoing studies before and after the Second World War, as a result of the studies of Robert Oppenheimer, also known as the father of the atomic bomb, he adapted the uncontrolled fission as a bomb, and one of the greatest human shamas known fell on the Japanese in 1945. Every big step we take with the power we take from nature and the contribution of science, as long as we respect nature and do not harm the environment, it will be beneficial to humanity. Accidents and mistakes can be minimalized but not always avoided, and what causes natural events that people cannot prevent cannot be predicted. On April 26, 1986, an accident started leaking in Chernobyl nuclear power plant in Kiev, Ukraine, and a lot of fission products were released into the atmosphere. This accident was felt as an increase in radioactivity in a wide area, England, Wales and Bulgaria. The most affected were the emergency workers and the rescue officers, which were 600,000 in the near future. Entry and exit to the region is still provided by police control, and entry and exit to some areas is still prohibited. As a result, until 2002, more than 4,000 thyroid cancers were diagnosed in this group. It is very likely that most of these thyroid cancers are caused by radioiodine intake. Radioactivity affecting plants and animals affected not only living people, but also subsequent generations fed from plants and animals. Secondly, as a result of the 9.0 magnitude Tohoku earthquake and tsunami in 2011 in Japan, the reactors in the Fukushima plant were flooded. This situation, which has occurred due to the failure of electrical and cooling systems and still continues, is the most complicated accident that has occurred since it contains all the reactors. While efforts to prevent nuclear disaster continue in Japan, the number of deaths is increasing day by day. Radiation was found in Tokyo city water. Meanwhile, the radiation reached Iceland. Security and environmental protection and nuclear energy in our country. It is within the knowledge of all of us in our country, coal mines, construction sites, industrial zones and factories that occur as negligence and pure accidents. First, environmental culture and security should be ensured, then the needs should be acquired and a job should be initiated. This idea can of course be called no. It is also an option to put our hands under the stone, set up the facilities and keep the security measures tight and to advance by acquiring technology and requirements. However, rather than putting ecological balance and human life and health under the stone, my personal opinion can be renewed rather than nuclear or fossil fuel, to give the society awareness of energy saving and energy producing companies, favors wind or solar energy. If the necessary studies focus on renewable energy, our world will remain greener. It is a fact that the risks will be almost zero for human and environmental life. On the other hand, I mentioned in my article about the damages that nuclear power plants may cause by accident, and the losses of fossil fuels are all known to us. The evaluation is of course yours.